After doing the last video, I took a quick look at the next problem, example 5, and I thought, they want to know what values of x where the graphs of the two f of x and g of x are going to intersect. And I thought that would be a perfect problem that I would use my calculator for so that I can see what those graphs look like. However, when I initially did this problem, I did do it by hand, so it will work out rather nicely algebraically. But since we've already done so many problems algebraically, I'm going to do example 5 in my calculator. So I'm going to start by, when I enter things into my calculator, I'm going to start with f of x being y1 and then g of x being y2. So let y1 equal the natural log of x plus 15 minus the natural log of x. I can make this a little bit bigger so we can see it. And then let y2 equal the natural log of x plus 3. So I put this into my calculator. So y1 and then y2. And then I'm going to hit Shift F3 because I don't know what my window looks like. And then I'll press draw. And you will see that there's going to be exactly one intersection point. And that's because this blue graph has a domain of 0 to infinity. So anything to the left of 0, there won't be an intersection point because this blue graph completely is out of that domain. So my only answer is going to be this value right here. So I hit G-solve and then intersect. And there you go, x equals 3. And that's how simple it is to do in the calculator. So I'm going to come over here. I'm going to say x equals 3. And box that answer. Now, if you were to do this problem by hand, you would end up with a quadratic where you get x equals -5 and +3. You would plug -5 back in and see that -5 is outside of the domain for not only this function right here that's part of y1, but also for this function right here that is part of y2. Voila, you can't have x equals -5 being a solution to which it causes a problem in the domain. Okay, the next problem I'm going to do by graphing as well. And, you know, I said that each example was going to be a different problem, but since this is so quick and easy, actually, I'm going to make it a separate video. So the next video will be example 6.